Okay, welcome to Network Tokens 101. We're just going to give everybody a few minutes to join here. But yeah, expecting a great turnout of people from all sides of payments. We've got some merchants, payment service providers, people who are just interested as well. So yeah, thanks for joining, Liam.
No problem. Thanks for having me. It sounds like it's going to be a pretty good turnout, definitely.
Yeah, for sure. People are very punctual already, which is great. So for people who just joined, there's two features in the webinar. There's a question section and there's a chat section. So as the presentation goes on, feel free to just ask questions in the question section. We have some people from the Evervault side here who are very well trained on network tokens. You can kind of answer your questions directly, but we'll cover them at the end as well. But yeah, curious to hear where everybody's dialing in from. I know there's a few familiar faces in here, but yeah, where is everybody in the world? New York City. Me too.
Nice.
How you doing, Owen? Hey, Andrew, South Africa. Hopefully it's a bit more sunny over there.
It's almost certainly warmer than it is here. Maybe less than Michigan.
Yeah, Michigan can get pretty cold. San Francisco, thanks for joining at the start of your day.
Good mix. So funny you were talking about weather. So I was looking at the news the other day, and obviously around the Great Lakes, they've had all that snow. I don't know, it's actually caused by the lakes or something. I don't know what it is, but as much as we complain about the weather in the UK, I was like, yeah, it could be worse.
Yeah, it never gets too cold, never gets too hot. The range is pretty small.
Absolutely.
Great, we'll give it another couple of minutes here. Vogsphere, it sounds more like a company than a city, but if it is a city, I'm glad to learn it.
Or of course it could be a company that's big enough to be its own city.
Exactly. Chicago. Great. Okay. I think we'll kick things off. A few more people join. We are going to be recording this whole session, so if you have to drop out for a little part of it, that's totally fine. You should get an email after the webinar with a link to the recording, and then yeah, some more context on network tokens in general. But yeah, to kick things off, I'm Shane. I'm the founder of Evervault. We're a payments data security company, helping companies control their own card data, and then implementing all the kind of payment extensions that you need to use card details across multiple payment processors. So things like 3D Secure, account updater to keep your cards up to date, and then yeah, the topic of this webinar, network tokens. So pretty excited to get into the weeds on all things network tokens and how they work. Over to you, Liam.
Awesome, thanks Shane. Yeah, so my name's Liam, and I'm the head of payments and compliance for Tebex, which is an Overwolf company. So Tebex is a customer of Evervault. We are a merchant of record platform. We specialize particularly in the gaming space, so studios, modders, kind of content creators within video gaming. We act as the merchant of record. We make sure that their products can be purchased and enjoyed globally by gamers across the world without having to deal with the headaches of, you know, sales tax and compliance and all those sorts of things. And as I said, obviously, payments and optimizing payments to get the best experience and the best results all around is a big part of what we do. So we use a bunch of Evervault tools as part of our kind of ever-widening tool scope to make sure we can do just that.
Cool, that sounds great. And just as we're kind of running through the agenda here, as a reminder, you can ask questions in the chat or in the question section. We'll try kind of get to them either during the webinar or in the Q&A section at the end. And hopefully there's a bunch of questions on network tokens, because normally there always is. So just to give a quick summary of what we're going to talk about today, we're going to speak about tokenization in general, what it is, why people use it, a little bit about network tokens, how they differ from normal tokens and kind of the tokens that a lot of us are used to, the security features of them. And I think this is where the meat of the webinar is going to be. Why should you use them? Are they actually useful? As well as some kind of gotchas and top tips, because we've been running table talks and having a bunch of conversations with merchants and PSPs alike over the last number of months. And I think network tokens are just one of these things where everybody's interested in them. They're a very hot topic, but nobody really can get good information or content about how they actually work and how they can use them in their business as well. So to answer the question of just what is tokenization and what are network tokens, tokenization is basically the process of taking a card number or a sensitive value, so say the 16-digit PAN that you get in the front of a card, and then converting it into a non-sensitive value. And normally this is where the card details get removed from your system, moved to some third-party provider, whether that's a PSP, a vaulting provider, or any other service really. And the big advantage is that you no longer have sensitive data in your systems, so things like PCI compliance are no longer a problem. And there's a few different types of tokens depending on how you want to store them. Do you want interoperability with different third-party services? But at the core of tokenization is a token vault. So this is the service where tokens are generated, it's where they're stored, and it's also where they're mapped to the original sensitive values. So you can kind of reverse a token back to the original 16-digit card number when you actually want to process a payment. So we'll get into some of the more kind of technical terms later, but typically the companies that provide tokenization services are called token service providers. They generally don't market themselves this way, but in line with the specifications, this is how we're going to refer to them throughout the webinar. And we'll kind of use the acronym TSP as well as we're running through it. So why do people store card details in the first place? I think the main reason is that it gives you huge flexibility. So if you've implemented one payment processor, you're using their payment iframe, and you're replacing the card details with a token from your PSP, it means you're saving a massive amount of time, money, and also just complexity from having to deal with PCI compliance. So everybody that's handling credit card details online does need to be PCI compliant, but PCI is one of these things that's kind of a spectrum. So you can reduce scope and you can kind of increase scope. But for most merchants, the thing they care the most about is actually selling their product and accepting payments from their customers. And compliance just generally isn't a core competency. So that's why you'll see the rise of the payment iframe that's happened over the last kind of 10 or 15 years or so. It removes merchants from scope to the greatest extent possible. They don't have to worry about PCI compliance on their backend infrastructure. And most merchants are storing some form of card token. And it's generally one of these three categories. So there's processor or acquirer tokens that you get directly from your PSP. So if you're using Stripe or Adyen, they'll give you a payment iframe. You'll get a token back that might necessarily look like a card number. You can store that, but you're locked into only using that token with a particular PSP. And then in some cases, merchants end up storing kind of multiple payment tokens if they have a multi-PSP approach. There's universal tokens that are provided by vault providers. So that's companies like us. There's a number of other companies that are kind of providing these services alongside payment processing as well. These work more or less the same way. You get a payment iframe, except instead of just having it work with one PSP, you can write those card details to any third-party service provider or payment processor, as the case may be. And then the third, and this is what the majority of the substance today is going to be, there's EMVCo payment tokens, which is a kind of less glamorous but more accurate description of what network tokens are. So these are normally requested by a payment service provider or a token service provider, like I mentioned on the last slide. But unlike the other types of tokens where they're issued by either a PSP or a vault provider, these are actually kind of created or requested by the card issuer. So if you've got a Chase card, typically Chase are involved in the provisioning of those network tokens, and they're the ones that maintain the mapping of the token to the original card number. And kind of giving a quick overview here of the pros and cons. I'm not going to run through all of the different variations of the different types of tokens, but the one that we're going to focus on today is network tokens. So they can be merchant specific, not necessarily by default, but we'll cover that later. They can be used with any payment service provider. They're not in scope for PCI, which is a kind of major advantage, but they do come with some drawbacks as well. So they're generally a lot more expensive to provision than kind of using a payment processor token, which is normally free of cost. But once you have a network token, you can use that with any third-party PSP that will accept the network token. And it means you can optimize your payment routing and improve authorization rates as well, which we'll get to in a few slides' time. So the reason we organized this webinar is that everybody's talking about network tokens. And in the last few months, some of the card networks have really been pushing network tokens as something that merchants should be focusing on. So Mastercard have claimed that manual card entry for online payments, in other words, click to pay, which is a variation on how you would implement a network token, manual card entry is going to be gone in Europe by 2030. So 2030 is a long time away, but it's also not that far in the future in the payments world. So we'll see if this is actually going to happen in practice, but it's certainly a pretty bold claim. And I think this is why everybody is kind of scrambling to figure out how network tokens work and how they can actually implement them under the hood. So to give a bit more context on what network tokens actually are, they were designed in 2014 alongside Apple. So Apple kind of created a consortium or a joint venture where they were working with some of the larger banks in America, as well as the card networks, to allow payments to happen with mobile wallets. So specifically on your phone, if you walk into a store, you can use a network token under the hood rather than having everybody's card details stored in a phone and shared with any third-party point of sale provider or payment processor or acquirer. They're merchant specific in theory, so there's a reason there's an asterisk there, which we'll get to later. But the idea is that they're more secure, because if a network token is stolen, it can't just be used by anybody on some other third-party site. So there's a massive fraud reduction as well. And EMVCo, who are kind of like a consortium of the card networks, where they define standards for how payment processing should happen, specifically within the card space. They created this standard a little after the kind of Apple's Pay spec was locked in. But this is the kind of core standard that everything network tokens stems from. So when we're talking about network tokens, we're actually talking about EMVCo payment tokens. But the card networks have done a pretty good job of branding, what they are and how they work as well. Each of the card networks have their own independent implementations of EMVCo payment tokenization. And this is, to be very specific, where network tokens are actually kind of coming from, or how they're defined. So there's a lot of kind of 3- and 4-letter acronyms here for the various products, but Visa, Mastercard, Amex, and Discover would be the primary networks that have their own kind of standalone network tokens, or token service providers for network tokens. You can integrate directly with all of them, or you can use some sort of aggregation service, which we'll get to later. But normally these are requested by your PSP. So the majority of merchants, or very few merchants, unless you're kind of operating at massive scale, they're not integrating directly with these services. They're using some other third-party service to do it for you. And in that case, that's a token service provider. And I think in summary, EMVCo tokens are kind of underpinning a huge amount of modern card payments without people necessarily realizing it under the hood. As merchants, you might get your gateway token or your payment processor token, but you don't actually know under the hood whether that's a network token that's being used for the payment processing, or whether it's just kind of converted back to the raw pan to be passed on to the banks under the hood. But mobile wallets by default are network tokens. So I think for a lot of merchants who are doing primarily mobile payments, or maybe they just have a high propensity of mobile wallet payments in their site in general, they're using EMVCo payment tokenization. And the difference between kind of e-commerce network tokenization and mobile wallet tokenization is that with mobile wallet tokens, the tokens are restricted to a specific device, whereas with e-commerce tokens, or kind of card and file tokens that we'll get to later, they use the same EMVCo specification, more or less, except they're requested directly by the merchant through a token service provider. So they're kind of linked between the merchant, the card holder, and the issuer, whereas with mobile wallets, it's the device, the issuer, and the card network. So there's a slight kind of subtle difference there. But once you have the token, whether it's a mobile wallet token or an e-commerce token, they can be used in pretty much the same way. They implement the specifications slightly differently, but when we're talking about network tokens in this presentation, we're mostly referring to the e-commerce use case and not necessarily the mobile wallets use case. But a lot of the advantages that you get from network tokens, you're actually already getting if you're doing kind of a high volume of payments online using Google Pay or Apple Pay or any of the third-party services. So in summary, mobile wallets and kind of e-commerce network tokens are both EMVCo payment tokens. They provide more or less the same advantages, and they're sometimes used interchangeably, but there is a subtle difference between them there. So before I kind of move forward, Liam, is there anything I kind of missed in defining what network tokens actually are?
No, I think that's a really good summary. One thing I would say that's kind of more an interesting thing, that sometimes I know I've spoken to people where, like you've said, each of the card schemes have their own kind of flavor of network tokens. And I know when I've kind of been to payments events, people have been like, oh, but we don't have to deal with multiple different standards, whatever that might be. But actually, it isn't any different from the way 3D Secure works. It's the banking industry, the payments industry have done a very good job of just branding it 3D Secure, and you say 3D Secure, and people know what you mean. But actually, underneath that's verified by Visa, that's Mastercard Secure Code, that's whatever the Amex one's called that's gone off, just disappeared from the top of my head. So it is something that, like you said, the actual implementation is a TSP problem, but actually it's something that we're very familiar with in the payments industry. It's exactly what we do for 3D Secure as well, in exactly the same way.
Yeah, for sure. And I think people are generally a little bit hesitant to talk about network tokens in the context of implementing another third-party service provider, just because, as I think a lot of us know, payments is very much a game of abstracting and integrating with dozens or as many kind of third parties as you can under the hood to do optimization. So I think people kind of panic a little bit when they think they have to integrate another bunch of services just to use something that's in theory meant to be already embedded as part of their payment flows.
Exactly.
So to kind of talk a little bit more about the flows themselves and kind of going a bit more granular about how network token provisioning and processing actually works. We've got some diagrams here that kind of talk about network tokens in the context of creating network tokens as well as processing the payments using them as well. So in summary, to create a network token, you're still collecting the raw card details from your user, whether that's through your PSP's payment iframe or whether it's directly yourself because you want to handle the card details and you're happy to take on the PCI compliance overhead. They then use the token service provider from the user's card brand to create the network token. So if the user puts in a Mastercard, you're going to integrate with Mastercard MDES and send the request to them. But typically the token service providers are kind of like a gateway that sit between the hundreds or thousands of card issuers that are integrated with each card network. They kind of, similar to how actual payment processing or 3D Secure works, you send the card network or the token service provider the card details, they go off to the issuing bank. And similar to payment authorization, there's a similar step with network token creation where the card issuer, instead of authorizing a particular payment, they're actually authorizing the creation of the network token itself. So it's not necessarily that you're guaranteed to get a network token if you have a user's raw PAN. The success rates for those transactions are generally very high, but there's no guarantee that you're actually going to get a network token back as well. So in that flow where you have multiple card brands that you accept from your customer, you do end up having to implement multiple token service providers to get the right token unless you're using an aggregation service. But basically, you collect the card from the user, you send it to the token service provider, and most of the time you're going to get a network token back. You can then just store that in your database. They're not subject to PCI. And at a later date, when you want to process a transaction using a card and file, whether it's recurring or whether it's a customer initiated transaction, you can just use that token going forward for the payment processing. So kind of to go into more detail on the payment processing itself, the network token is sent to the payment gateway in the same way that you would with a normal PAN or a gateway token. But instead of sending the card details, you're sending the network token. They're passing the card or the network token along to the card network. And then I think interestingly, once a transaction is going to the issuer for payment authorization, the issuer actually just receives the original raw 16-digit PANs. The card networks or the token service providers basically swap out the token for the original PAN, and the card issuer is using that data to authorize the payment. But they do get additional metadata that says the transaction was completed using a network token rather than a raw PAN. But the reason it's kind of a little bit more kind of robust than just handling a raw PAN is that only two of these sort of steps in the diagram are handling a raw PAN. So the card details are just handled by the issuer, who already has the card details because they're the ones that issued the card, and the card network, which kind of greatly reduces risk of data breaches. And I think this is one of the reasons that the networks themselves are kind of incentivizing and encouraging merchants to use network tokens. One of the kind of nice advantages of network tokens is the kind of reissuing flow. So if you're handling a raw PAN, a lot of merchants are already using these card account updater services, which again, you can sometimes get from your PSP. Some people are integrating directly with the card networks, but in a scenario where a card expires, on average every year, 30% of issued cards end up being reissued for some reason, whether it's expiry, stolen card, lost card, or something similar. You basically get a webhook from the card network. They're great services, but they're generally speaking just quite expensive, especially if you've got kind of a low margin business or a business where you're just revenue from each payment is generally quite low. So I think a lot of merchants kind of opt out of using this, and they'd rather kind of eat the churn risk rather than kind of getting the keeping the account details up to date. what's nice about network tokens is they actually have this functionality built in. So it's called card account lifecycle management, or at least it's marketed that way. You get very similar notifications as in comparison to card account updaters. So when the card is reissued, the token service provider sends notifications to anybody that's integrated with them with the new network token, the new expiry, and you can kind of keep that on file. So if you've got a monthly subscription business or something similar, in real time, you're getting these updates. So when you're doing a batch payment or something similar, you know that the card details are valid and you're not going to have significant churn because the card details have expired. Sorry, go ahead, Tim.
So this is a really good point actually, and it's something that can be overlooked. So I've experienced this today, pure coincidence. Got a phone call from my bank this morning going, have you made a significant deposit to Skybet? Well, no, I hadn't. And thankfully my bank did all the things they're supposed to do, and they've identified it and they've cancelled it. Obviously my physical card has now been cancelled and I'll get a new one. But I will now know the companies that are using, most likely, like you said, kind of automated updaters using network tokens, because they're more likely to do it, and those subscriptions will probably carry on if I've got my subscription to the news service I subscribe to and various other things. Whereas the subscriptions that maybe now fail, and I've already had an email today from something that tried to renew and has failed, so they're obviously not updating the card details, or they're using an updater that's obviously not in real time. Now I'm sat here going, well, do I actually need that service, or am I going to go and cancel it? So like I said, I've had that experience today, and that's something that can be overlooked. Even the kind of, I guess, standard or old school card updaters aren't real time, are quite expensive, and you end up, when this happens, and unfortunately fraud is a fact of life, it happens to all of us. You do start going through, well, do I need to go through the effort of re-adding my card details for that particular service or not? So.
Yeah, I think that's one of the things from a consumer perspective that can be quite surprising. You assume when you kind of get a new card or something that all of your subscriptions are going to be cancelled, and just from a financial planning perspective, that can be quite nice. But I think a lot of the time from a merchant's perspective, they really want these services to work. But with card account updater, the traditional flow where you're requesting updates for raw pans, typically the APIs are a bit more dated. So you have to do batch updates, which can take a couple of days. And typically you'll do a batch maybe 5 days or something before the subscription billing is going to happen. Whereas with network tokens, they're not, literally real time, but they're pretty close to real time, where you don't have to do a big batch job and wait 48 hours for an update. You just kind of get everything out of the box through a webhook. And I think from a merchant's perspective as well, the nicest thing is that instead of paying something like 20, 25 cents for a card account update, normally with network tokens, these services are totally free. So the card networks don't bill for the updates, whereas with card account updater, they do, which is a nice advantage of using network tokens. So kind of tying all this together into a diagram, I'm not going to run through every single step here, but creating the network token, you're going to collect a card from the user as a merchant, send it to either the card networks directly, or in this diagram, we've slotted in Evervault as a token requester here as well. The issuer approves the token creation. If you get it back, you store it. And then when you're actually processing the payment, it works more or less the same way, except instead of passing a raw PAN, you just pass a network token, which is also a 13 to 19 digit number as well that looks quite like a raw PAN, which is something that I think Liam and I had spoken about earlier on, where it can be quite difficult to identify whether a network token is a network token or whether it's a raw PAN, because they look much the same, they still have bins and so on. So that's definitely something to think about, is if you have an environment where you've got some network tokens and some raw PANs, identifying which one is which does require looking up the bin on the card to know whether it's a network token or a raw PAN. So on the point of kind of authorization rate uplifts, which we'll get to shortly, the big reason why the card networks are pushing network tokens is mostly for security reasons. And back to the original point on, I think it was the second or third slide, where I said the network tokens were merchant specific. I'm going to explain a little bit about why that's not necessarily true. Network tokens is this concept of a token requester ID, which we'll define in a second, but we're just going to cover why are network tokens more secure, and I guess why are the card networks pushing them so much. The biggest advantage of a network token from a security perspective is that they can't just be used anywhere. So if you're a merchant, you have a database full of card details or network tokens. If the network tokens get breached, someone who steals that data can't just take the network token, go to a merchant site, whether it's Skybet, like you mentioned, Liam, or some other third-party service, paste them into the checkout page and have them process the payment. They have to be kind of directly sent to the payment gateway as a network token. So the stolen network tokens can't be used by fraudsters for malicious payments unless they have a direct kind of acquiring bank relationship, which would be a much more sophisticated attacker, and I think something that most data breaches don't necessarily fall foul of. But on the point of network tokens being bound to specific merchants, that can be true. So network tokens have kind of a reasonably technical feature called token domain restriction controls, where when you provision a network token, you can specify effectively policies for how this token can be used. So in the Apple Pay example, the token is created and it can only be used by a specific iPhone or Android device or whatever. For an e-commerce service provider or merchant, you can specify a token control that says that this network token can only be used by a merchant with a specific merchant ID. But in practice, most of the services that are provisioning network tokens for you don't actually enforce these controls because they require pretty low level access to the APIs directly from the card network. So they just abstract that. And actually a lot of payment facilitators who are kind of using umbrella merchant IDs and sub merchants, they actually just provision network tokens for a cardholder once, and then the same network tokens actually get used across a bunch of different sub merchants, mostly as a kind of cost optimization thing. But by default, network tokens aren't actually restricted to a particular merchant. They can be, but in practice, that's not always the case. But in general, when you implement these token domain restriction controls, which is a bit of a mouthful, it massively reduces the fraud footprint of a stolen network token. And as a result, issuers are more likely to authorize the payments because they kind of get much better guarantees that this network token isn't being used for something that it wasn't originally authorized for. And this is where the distinction between token requester IDs and merchant IDs come in. Every set of controls that you define in a network token gets assigned to a token requester ID, which is quite similar to a merchant ID in that you specify the merchant name and the policy itself. You get an ID back that's used for kind of the token domain itself. But a token requester ID is not the same as a merchant ID. And the token requester ID is meant to be specific to an individual kind of company or group, but that's not always the case, like in the example of the payment facilitator that I mentioned earlier. Cardholder verification is the other interesting part of network tokens. So normally for a card not present payment authorization, as consumers, we always kind of put in our card details and you're prompted for a CVV, which is the kind of 3 or 4 digit code on the back of the card. Network tokens are different, where when you're provisioning the network token, you can optionally provide the CVV that the consumer passes to you. It does increase the likelihood of the network token being issued and a higher just likelihood of approval there. But once the network token is returned, in general, you're not allowed to store a network token after authorization, but the network token is the only kind of sensitive field that you actually have for authorizing the payment. And when you're actually processing a transaction using a network token, the difference is instead of passing a CVV for a customer-initiated transaction, network tokens have this concept of a cryptogram. For recurring payments or merchant-initiated transactions, you don't need to pass a cardholder verification value like a cryptogram. So you can just try to process the payment. Maybe you pass additional metadata like the user's address or zip code or something similar. But for a customer-initiated transaction, you send a request back to the token service provider saying, I have this network token. I'm looking to authorize a payment for $100, and then the issuer will issue a cryptogram which can only be used once, and this gets passed as part of the kind of card processing payload as well. So cryptograms are kind of like the network token equivalent of a CVV, but the user isn't actually involved in that step. The issuer kind of dynamically decides whether to return a cryptogram or not. Again, the likelihood of getting a cryptogram when you have the network token kind of authorized and provisioned is extremely high, but there isn't necessarily a guarantee there, and it's kind of a risk-based decision for the issuers. The cryptograms aren't 3 or 4 digits; they're generally 32 bytes of kind of alphanumeric characters, but they don't need to be stored. They can just be requested and passed directly to the PSP when the transaction is happening. Anything there on the security benefits, Liam, that I missed?
No, I think you've covered everything very well.
Cool. this is the section that I'm going to lean on you a lot for. It's all fine for me to say network tokens are great and you should definitely use them, but we're going to run through, do they really work? What are the benefits? I think aside from the implementation details, this is the biggest kind of piece of pushback or just set of questions that we hear from merchants who are thinking about using network tokens. There's a lot of numbers thrown around, and I think the big question is, for such a major, or generally speaking, a reasonably large technical integration, are they worth the headache, basically? So we're going to run through some of the benefits, and then I think I'll hand over to you to actually talk about what you've seen in practice at TEBx.
Absolutely.
So the official and sort of empirical set of advantages that we've seen from merchants is kind of two sets. There's the payment optimization side. So because of those security restrictions and because of the kind of lower fraud risk, generally speaking, transactions using network tokens see a much higher authorization rate uplift, or just a much higher authorization rate in general. So the official stat that was published by a report that Deloitte did a couple of years ago is, on average, merchants see a 2.1% authorization rate uplift when they use network tokens in comparison to non-network tokens transactions. What we've seen is somewhere between 1% and 4%. So the figures are somewhat accurate, but in a minute, I'll ask Liam to share a bit more about what he's seen. Secondly, acquirers are more likely to pass on lower interchange fees to merchants when they're using network tokens. Specifically, for example, next October, Visa are increasing the fees for what they call the Secure Credential Integrity Framework, which is currently 0.025%. So in the grand scheme of things, it's not massive, but at significant scale, it can be quite costly. And the SCIF framework is a transaction that's processed either using network tokens or 3D Secure. So they're really encouraging kind of stronger security guarantees and stronger security infrastructure for merchants. They haven't released an exact figure about how much the fees are going to increase, but it's going to be kind of significant. So multiples of the current cost. And then secondly, from a pure kind of compliance and kind of operational overhead perspective, because network tokens aren't subject to PCI compliance, you can effectively descope your entire environment. The one caveat here is that even though once you have the network token, they're not in scope for PCI, the step where you're collecting the card details from the user, sending it onto the token service provider, does still require handling a raw PAN. So you don't get as many of the security advantages if you're provisioning network tokens directly, rather than using, for example, a PSP or a token requester, token service provider type of product. So using network tokens, you can reduce your scope to something like the self-assessment questionnaire A, which is the most basic set of PCI controls. You can self-assess for that if you're processing less than 6 million transactions per year as a merchant. But if you're not, the most interesting thing from the card networks is that Mastercard actually have an exemption program. So if 75% or more of your transactions are being processed with EMV tokens or network tokens, they actually have a full PCI exemption program, which you do have to get approved for. But if you're a merchant doing, say, 10 million transactions a year, normally you would go through a full PCI level 1 ROC every year. Mastercard don't require that if more than 75% of your volume is done through network tokens. So it can be a pretty major compliance cost saving as well. Because network tokens are bound by the token domain restriction controls, like I mentioned a couple of slides ago, you do get much lower fraud rates as well. Because the network tokens can't be used for fraudulent purchases. You get a much better guarantee that a particular transaction hasn't been processed using a stolen card, especially if you're a high-risk merchant as well. So Visa claim a 26% reduction in card not present fraud for transactions using network tokens. I think from what we've seen, that's a little bit higher than what we see from merchants, but it's definitely kind of a double-digit percentage improvement in fraud rates as well. And then the final point on optimization is that network tokens are by design entirely universal. So they're not bound to a particular payment processor, they're bound to a token requester ID. So instead of storing payment gateway tokens in your database and processing payments that way, you can store the network tokens, and then in theory, you can share those with any third-party acquirer or payment gateway or payment service provider, assuming that they'll actually accept the network tokens from you as well. So when you provision network tokens independently through a token service provider, you basically get guaranteed flexibility across PSPs, which is a very nice advantage, and I think one that you guys have definitely taken advantage of at TEBx as well. So setting aside the kind of the marketing spiel about why network tokens are better, it'd be great to hear from you what you've actually seen. You've been using them for a while now, and whether this stuff is all accurate.
Absolutely. So yeah, we've been using network tokens for around just over a year, I think. And I'll talk a bit more later on about kind of how we got into it and those sorts of things. Probably a very common route. And a lot of the benefits that you talk about, we definitely see. Definitely, I think the thing to remember is that it's in the scheme's interest, as we've seen, Mastercard making their announcement about 2030, whatever else. It's in the scheme's interest to make it beneficial because they want everyone to be using these network tokens. So some of that, they're going to be trying to drive that adoption, like we see with some of the incentives around lower interchange fees and those sorts of things. Fundamentally, like you said, the schemes and so the processors and the schemes trust network tokens a heck of a lot more. They're seen as obviously having a much lower risk profile, and we have seen kind of definitely less declines. Interestingly, both kind of less issuer suspected fraud declines, but also less just general declines as well, particularly when it's like cross-border, those sorts of things that can often trigger kind of red flags. And again, being a gaming company, we have a lot of cross-border transactions. We're dealing with gamers across the globe. So we have seen kind of a reduction in those sorts of declines. From kind of other people I've spoken to, it can vary by industry. We see around about that 2% uplift in auth rates. So actually, yeah, right around that kind of 2.1 that's talked about generally. Like I said, we see in our space about 2%, but I certainly know colleagues in the space that have had higher rates as well. So definitely within that. Something that is kind of interesting is that thing you mentioned about the interchange fees and whether it's passed on. Now, I would imagine that most merchants that are looking at network tokens, and at least certainly looking at network tokens and not just via their PSP, are probably kind of on some form of interchange plus pricing. But that is, I think, an important thing to note, that if you're on some form of blended rate, Stripe, for example, by default, you have the blended rates. A lot of other PSPs, they'll kind of even out the processing costs across, all the cards from, US commercial cards to, a European debit card. At that point, you're not going to see that benefit because you're not paying the interchange fee. But it is something that, like I said, if you're on an IC++ type pricing structure, I think from my knowledge, the discounts that people are seeing are up to about 10 bips, which, it doesn't sound significant, but like we've said before, if you're processing, millions and millions of dollars of transactions or value of transactions in a year, that 10 bips does become significant, 100%. For us, the other thing that we like is really that flexibility. There are, other ways of doing it, like using kind of more traditional kind of vaulting solutions. But the issue again with a lot of those is it's adding more steps as well, and almost more points of failure. So if you have, or rather more points of failure, or you have to handle the raw CHD, the raw cardholder data. If you imagine you've got a token that you need to convert back to a card number before you can make the request, you've either got to send it via other routes, which again still then maybe has that vendor lock-in. If your tokens are specific to vendor A, you can only use vendor A. Whereas with network tokens, once you have that, you can route that through your PSP as long as you've got the relevant information. And like I said, that adds a lot of flexibility around what we do, for example, which is working with lots of different acquirers. We're a big fan of the champion challenger model. And so we're not, we want that experience to be consistent. We don't want to be in a situation where, like you said, you end up with a token, one token for acquirer A, one token for acquirer B, a different one for acquirer C, because then you've got a customer who, as far as they're concerned, they've checked out with you before. They've already purchased with you. They've saved their payment method. But you're now either locked into forcing them through the same acquirer every time, the same PSP every time, or you're going to have to ask them for their details again, even though you should have saved it, because you don't have a token that works with a different PSP. So for us, where we are actively routing through different acquirers, with the same customer, we want to have that experience from the CHD gathering to, if they've saved their payment method, we have the network token. We want that to be consistent, regardless of which acquirer we're sending it to. And as such, for that, we want to make sure that that this is what network tokens do for us. Finally, I just want to also mention on the PCI compliance aspects. I mean, the two things that are kind of interesting here, I suppose, is again, this doesn't, as Shane mentioned, it doesn't stop you from having to worry about how you collect your CHD. My personal advice, and I'm sure lots of people in here will agree with me, is remove your stuff from scope as often as possible. This is one of my, whenever we're talking to PSPs or we're talking to solutions providers or whatever else, it's like if we're increasing our kind of PCI scope, then that's not something we're interested in. If we're reducing our PCI scope, that's something we're interested in. When we actually started working with Evervault just over a year ago, we were looking at other vendors as well. And one of the vendors, their solution, certainly in my opinion, would have increased our PCI DSS scope, which was one of the key drivers as to why we went with Evervault versus a competitor. So for me, reducing that scope is always a big thing. And again, network tokens, as Shane said, is a really good way because the banks have that confidence that even if there's a leak, network tokens are absolutely worthless. You cannot key in a network token and process a payment. That's not how it works. The one slight caveat I'll put around this is certainly with PSP provided network tokens, something that the PSPs will often do is they almost have their own database of raw PANs to network token. And they will make a decision once they've received the raw card number, whether to use the card number or whether to use network token. Now, some of the benefits around knowing that it isn't a stolen card, you've suddenly lost because that could still be a stolen card that now just so happens to map to a network token because they've seen that card before. In my case, for example, someone has obviously stolen my card number. If they went through a PSP that has that, they could still key in my number and it would then map to a network token. The PSP then presents the network token. And you lose some of those bonuses. It'll be interesting to see whether there is any kind of future changes in the guidance around that, because I think that is, from the scheme side, it's one of the big advantages that's kind of being undone with these almost like lookup tables that some of these PSPs have. So it'll be interesting to see how that, or if that is impacted in any way. But certainly for us, we've seen a significant uplift. We love the flexibility. As I said, we want to be as flexible and as agile and be able to change our routing, sometimes multiple times a day. And network tokens provide us with the ability to do that while getting rid of the vendor lock-in and some of the restrictions of maybe the more traditional solutions around it.
Cool, that's great. We're going to kind of dive a little bit more into your story with network tokens because I know you've had a pretty interesting journey in actually using them. But in the meantime, I just want to run through some of the basically like frequently asked questions that come up all the time that you can't find answers for in, frankly, a lot of the kind of AI generated marketing content online about network tokens. But first, just in terms of how you can actually use them, payment service providers are the kind of main way that most people tend to integrate. If you're a merchant that just uses one PSP, in a lot of cases, it can just be a case of flicking the switch, especially if you're storing cards on file with the PSP themselves. But one thing to note is that in many cases, the network tokens aren't actually yours. In that PayFac example, where they're kind of managing an umbrella token requester ID that's used across some merchants. If you want to go multi-PSP at a later date, or even just switch payment service providers, you're going to have to re-provision all of those network tokens again. And if you don't have the raw PANs or the CVVs, it can be pretty tricky. Mobile wallets, like I mentioned at the start, they are network tokens. So if you have an Apple Pay or Google Pay integration, congratulations, you're already getting a lot of these benefits. And then the third is building a direct integration with the networks. So maybe 80% of your volume or something is Visa and Mastercard, and you can just kind of say, we're going to use network tokens for those two schemes and ignore maybe some of the kind of longer tail schemes. But if you want to, you can you build integrations with all of them, do bin lookups to identify what a raw PAN or who a raw PAN is issued by, and then send it to the correct token service provider, which is definitely the most optimal from a payments performance perspective, because you get a lot more kind of fine-grained control, generally speaking, lower costs. But it comes at the expense of actually building the stuff. There's also third-party network tokens APIs. We're kind of token service provider aggregators. So this is what we do. They're basically just single APIs that you can integrate with to handle merchant onboarding, token provisioning, and cryptogram generation for the payment processing itself. How these are different to PSPs is that they're universal. So once you create the token, it's yours. You don't just get another token that gets mapped back to a network token that becomes tricky to migrate. And they're kind of directly integrated with the card networks as well. So there's no kind of middlemen handling kind of payment processing on network tokens. It's just a raw API that takes a raw PAN, gives you a network token back, and you kind of can then decide how you want to write the network tokens and so on. So that's sort of a nice halfway house between integrating directly with the schemes for the kind of cost and customizability advantages. But on the upside, it also saves honestly months or in some cases years of negotiation with the card networks to get access to the token services. Some of the card networks are very restrictive about who can integrate directly with services like Visa VTS or Mastercard MDES. And if you're kind of a merchant that's not doing even billions in card payments per year, sometimes it can be pretty tricky to get those integration projects kicked off. On the frequently asked questions, there's 5 of them that we're going to cover, but one of the kind of most entertaining ones is when we speak with merchants who do a trial of network tokens. So they use some third-party service to provision the network tokens, and they say, there wasn't really much of an authorization rate uplift. And you kind of dig into it a little bit, and what turns out to be true quite a lot of the time is that people are actually already using network tokens if they're storing their card on file with the PSP. And then you're comparing a baseline of independent or universally provisioned network tokens versus the network tokens that are being provisioned on your behalf by Adyen or Checkout.com or Stripe or whoever. So it's definitely worth double checking that. The second, and it's something I covered earlier on, is that merchant IDs and token requester IDs are not the same thing. Token requester IDs are tied to the specific set of restrictions on the network token itself, whereas merchant IDs are, generally speaking, just the bank account number of your merchant account that you have with whatever kind of traditional bank is handling that under the hood. Issuer support is definitely something I'd like to kind of chat with Liam about in a minute, but it does vary quite a lot. So if you're operating in a geography that's generally a bit more kind of modern in payment infrastructure, like the US, the UK, and the EU, issuer support is generally very high. So in the UK, for example, there's only one major bank that doesn't support network token issuance. But in emerging markets, it can be significantly lower, especially when you're dealing with kind of local card brands or card networks. In some countries, it can be as low as 40% or even lower in smaller countries as well. So one thing to note is that even if you implement network tokens and you're getting all the advantages from them, you're always going to need fallback logic, where for cards you can't provision a network token for, you'll need to store the PAN or a gateway token or something similar, unless you're happy to just kind of lose the user's business, which isn't great. So it's not really a binary choice. It's either you use network tokens plus PANs or you use PANs. You can't kind of just use network tokens, which is a slight shame. But over time, I expect this will probably improve quite a lot, especially in some of the more emerging markets. Probably the biggest challenge with rolling these out, if you decide network tokens are great, we want to use them, and we're going to kick off the engineering project to implement them, getting your PSP to accept them can be pretty challenging, to be honest. Similar to how they kind of encourage you to use their payment iframe and their card vault, so their product's a bit more sticky. If you provision a network token, you have a database full of network tokens for your users, and you want to pass them onto a PSP. Most of them were kind of, I'll call them modern payment processors. They generally have no issues in accepting them, but a lot of the time it can be a case of escalating it internally. You kind of have to move beyond your account manager up to maybe a product manager or something similar. So that can be quite a painful process. But some of the PSPs are quite good about accepting independently provisioned network tokens, especially for larger merchants as well. And then finally, payment authentication. So in countries like Europe, where 3D Secure is mandated by the SCA provisions under PSD2, you can do 3D Secure exactly the same using a network token as you can, or as you do using a raw PAN. Because they're 13 to 19 digits, you just pass them into the 3D Secure server APIs, and everything happens the exact same way on the payment authentication side. So you can use them in a way that's SCA compliant, and you can also do the liability shift or take advantage of the liability shift that comes with 3D Secure as well. So that's kind of just a small implementation detail that I think is worth noting. Liam, I think it'd be great to hear a bit more from you about just your story of network tokens. And I know we've been working together a little over a year now. But before that, when did you start using network tokens? And I guess just kind of tell us the story.
Yeah, absolutely. So there's a few things I'm going to touch on while I talk about this that will kind of refer back to other things that we've already talked about. But so TebEx has been using network tokens for about 2 years now, I think it is, 18 months, 2 years, something like that. And our kind of journey into them will probably be very similar to what a lot of merchants would do. We started off doing it through one of our acquirers. Not going to mention names. And that's what it was. It was like, hey, let's turn it on. Let's let them handle all the provisioning and kind of when the network tokens are being used and those sorts of things. And that worked really well. As I said, we saw kind of immediate uplifts in auth rates. We saw immediate benefits around kind of, both reductions in some of the fraud that we would see and those sorts of things. But also, as I mentioned, we're a big fan of the champion challenger model, and that's something that we weren't getting. We don't like to rely on a single acquirer, a single PSP. We certainly don't want to just assume that the PSP we've been using for the past 10 years is still the best. It would have been the best when we made the decision, but that doesn't necessarily mean it's the case. And this is one of the reasons why actually we started talking to Evervault, because the things that we weren't seeing, things that we were having challenges with, were around kind of portability and in having that consistency between different PSPs. That doesn't just relate to network tokens, but also kind of just the collection of cardholder data in general. As Shane mentioned, the standard way that most PSPs work these days is they will give you an iframe or some form of like JavaScript that creates iframes, or however it might be, that collects the cardholder data, that keeps it out of your scope, which is brilliant. It's like the best thing that someone ever came up with, but it is still tied. And if you're then wanting to route, say, for example, based on BIN, let's say that actually a certain BIN or a certain bank, you get better performance through a different acquirer. Well, you can't do that until you know the card number, or at least until you know the BIN, which if that card data collection is locked into a PSP, it's too late. You can't change it by that point. So we slowly started moving out of that space and into the kind of third-party space with Evervault, to the point where now we're relying on Evervault to help us collect cardholder data for hundreds of thousands of transactions a month. As Shane said, you're always going to have that backup. You're never going to be able to just rely on network tokens. So, cardholder data and all of these vaulting solutions will have something like what Evervault call Relay, which is where you kind of squirt the token in, you proxy your request via whoever, and then they inject the raw cardholder data again. So it's never touching your environment. You're staying firmly out of scope, which is brilliant. But you still have that control to say, right, I'm going to route this request to PSP A, this request to PSP B, and so on. We're now actually shifting kind of 3D secure to being vendor specific, to being via Evervault, because again, it means it's a consistent experience. We're comparing like for like when we're comparing the performance of PSP, our champion and our challenger. We want it to be a fair fight, as it were. So we want to make sure that all the variables are as consistent as they can be. And also one of the things that again, Shane mentioned for us that's been important is the granular control. So we want to be able to, even if we've got a subscription, just because we've set up a customer and they've got a monthly renewing subscription, historically, the way we had to work is because the network token was owned by the PSP, you would always have to go back to that same PSP. I'd have to renew it with the particular PSP. Well, if we've either left them entirely for whatever reason, or we want to see how it performs with the other PSP, or even if there's a temporary fault and we just want to fail over, by having the network token, by doing it via network tokens and having the network tokens outside of the PSP, we can immediately go, right, we're going to make that exact same renewal payment, but we're going to send it to a different PSP. And so, like I said, the benefits there of that control, that granularity, we do routing now down to the bin level. We started off when we first did it, our champion challenger was kind of at country level. So we go, right, we'd look at a country like Brazil, for example, where maybe less interested in network tokens, but you have the challenges around local cards, ELO, HEPA card, those sorts of things. And we wanted to kind of gauge the benefit. we can, having that granularity to route at the country level was kind of how we started. We're now looking at, particular bins, particular banks that maybe for whatever reason, just we're not getting the success with a particular acquirer that we work with, and we'll try one of our other acquirers and see if they get more successful, whether it is a kind of more widespread issue. The thing I will say, and Shane did touch on this, is that clearly doing it with the PSP is a heck of a lot easier. You just, when we first started, you said 18 months ago, 2 years ago, it was literally, we pressed a button and that was it. We didn't have to do anything else. It was super easy and a great way to test it out and see how it would work. To do it via a third party, oftentimes what we found is a lot of the PSPs, even though they do allow it, it either isn't documented or the documentation is not very accurate. The kind of MFCOs, do specify standards on what certain things are called or how things should work. But a lot of these APIs, I think because they're trying to be helpful and they try and remove some terminology, will call fields different things. So, you might get the cryptogram from Evervault or whoever, your TSP, but actually they still want you to send it in the CVC field or CVT field, whatever they call it. And so some of that can be challenging. We've ended up having to jump on a lot of calls actually with the kind of solutions engineers, not just product managers, to actually understand how do we send this data to you. And we found that in quite a few cases. So being a tech first company, TebEx is tech first. Our founder was our first developer. Before I became head of payments compliance, I was a developer. We invest a lot of time and energy and resources into our development team. And it is something that makes life a lot easier. That said, and I've not been paid to say this, but maybe I should ask for some. Evervault made that super easy in a lot of ways. They've been super helpful with, translating sometimes. So we've had requests back from our PSP and we've gone, well, they've asked us for this, but we don't really understand what they mean. And someone at Evervault will go, oh, they want you to send this, this, and this. And we're like, oh, awesome. Great. When we had to do our AOC for our PCI DSS compliance, Evervault were a massive help with that, giving us a lot of the information that we needed and helping us through that process. So for us, we're always looking to level up our tooling. We're always looking to have more control, have more granularity without the headaches of going direct to Visa and Mastercard, because, that's not something that they would be interested right now. And we don't want those headaches. We've got much better products to be spending our time building. But having that control, that granularity is something that, taking the network tokens outside of the PSPs to the likes of Evervault or whoever else has really made a difference for us.
Great. I'm sorry to interrupt. I know we're kind of coming up on time now, and there's a load of questions in chat that haven't had the chance to be answered yet. So I'm just going to kind of run through some of the main ones. I think one of the ones that's most relevant and interesting to merchants is pricing. So this came up in a couple of questions actually, but there's basically just two billable events for network tokens. There's a cost to provision them, and there's a cost to generate a cryptogram. There's nothing else except for your payment processing fees that kind of kick in there on the billing side. But to give you a reference point, it's about a cent, give or take at scale for provisioning a network token, maybe kind of 2-3 cents in some cases. Bin lookups as well. So you can do bin lookup based on network tokens. Most of the bin databases from the card networks also cover the bin ranges for network tokens as well. Cancel cards. Customers, when they cancel a card, it depends on how they cancel it, effectively, whether the network token is updated or not. If the card is just reissued because it's lost, then the subscriptions continue. If they freeze their card, then the network tokens are also frozen as well, and you can't process transactions as well. I know there's a lot more kind of detail that needs to be covered as well, and I wish we had more time because I think we could talk about this for hours. But in the meantime, I just wanted to thank everybody for joining. If you do have any questions in the meantime on network tokens, feel free to reach out to me directly at shane@evervault.com, or Liam. I think you're liam.whiltshire at overwolf.com. And generally speaking, we're going to be sharing a recording of this webinar with everybody so you can look at it later for future reference. But thank you all for joining. It's been a great session, and thank you, Liam.
Thank you. Thanks everyone for attending. Thank you, Shane, for having me.
Cool. Likewise. Have a good day, everyone.